Good morning, guys. Today we're going to be looking at solving systems of equations. We're going to be solving specifically systems of equations involving three variables. And before we do, kind of going back to Algebra 1, so if you slide up here, or down here we see systems of equations. A system of equations, or linear equations, is two or more linear equations containing two or more variables. Okay, so this one on the left here has how many variables? This one on the left has two variables. In this case, the variables are x and y. And then this one on the right has three variables. X, y, and z. So you might have remember seeing these, the ones on the left from Algebra 1. And what we're going to see today over here is for Algebra 2. Okay. So systems of equations, and let me kind of zoom out here so we can see the full picture. Okay. So systems of equations, in Algebra 1 we learned a solution to a system of two equations like the ones that we see in red, right, on the top here. The solution is an ordered pair. So when I have two equations, my solution is an ordered pair. So what is an ordered pair? It's when you have something with coordinates, right? X, comma, y. So an ordered pair is like a point. You might think of it that way. Okay. And then a point that makes the equation true. A system of two linear equations can have one solution, no solution, or infinitely many solutions. And these pictures kind of illustrate the different types of situations that can happen. So again, if we're talking about a system of equations, if we have two linear equations, two lines, there's three situations that can happen, right? I can either have two lines that are intersecting. I can have two lines that never intersect because they're parallel. Right? So let me, what color do I want to use? Let me pick one that stands out. So I'm going to say we have one solution when the lines intersect, right? And two lines usually intersect at one point, right? So they usually intersect at one point. Then we have two parallel lines. So when the two lines are parallel, they don't intersect, so that means there's no solution. There's no point of intersection. Now, when I have infinitely many solutions, that means that, let's say these two red lines, if I move them together, so I have, let me pick those two colors. So let's say I have a red line, and then I have a blue line on top of that red line. So let's say I have I have a blue line on top of a red line. What happens when I mix blue and red? They make purple, right? So if I have two lines that are on top of each other, then how many points of intersection do they have? Well, if I draw them on top of each other, then they're always intersecting, right? So when we have infinitely many solutions, it's the case where we have one line on top, one line on top of another. Okay, so let's recap, right? So I can either have one solution, that means two lines are intersecting, and I have one point where they intersect. So what's the solution in this first picture? It's the coordinate 1, comma 1. So this is my solution, right? This is my x and my y. This is where the two lines intersect. Here on this red line and blue line never intersect, so there's no solution. And then here we have, if I have one line on top of the other, I have this red line and then the blue one is on top of that red line, it's always intersecting, so it has infinitely many intersection points. Okay, so now let's look at what we're going to be focusing on today is solving systems with three variables. And I'm going to lead you through the examples and kind of show you the steps. But a couple of terms and terminology is that we say a coordinate system in three variables is called a coordinate space. Right? So remember in geometry, when you were talking about three-dimensional objects, you have like spheres, cones, prisms, pyramids. Those three-dimensional objects had a coordinate system that was made up of three directions, right? X, Y, and Z. And we had a coordinate space. A point in this space is represented by an ordered triple. So remember we talked about an ordered pair. Now we have an ordered triple. Triple meaning three. Because now I can be located not just on the XY axis, but if I move the point up, then I can also move up or down, right? So it's kind of like if I'm walking around a room, I can walk around and I'm on the floor, right? So I can tell you where I'm at XY, right? But as soon as I take the stairs and I go up, then I'm at a new level. So I'm at like kind of a Z location. So I can move anywhere in a room like XY, but the moment I go like up some stairs, then I'm at a new Z height, right? Down here, we have another statement or definition. The graph of a linear equation in three variables is a plane. This is the same idea of a plane when you talked about in geometry. I think it was kind of the first chapter of geometry. You were talking about planes and lines and points and rays and line segments. So here we have a plane, but the graph of a linear equation in three variables is a plane. So you've seen these objects before, but now we're going to be looking at solving equations with these objects. A solution to a linear system of three linear equations, so now we're going to be looking at three linear equations, is an ordered triple. And this word triple should have been underlined and bold. That's all right. So I'm just underlining and bolding it. So an ordered triple, that makes the equation true. So we're going to end up with solutions that have answers of x, y, and z. And again, it'll make more sense when we look at the examples. But right now, again, I'm just going over terminology, some terminology from geometry. And then we're going to slide over to this page. Let me make sure. Yeah, it's pretty centered. Okay. All right. So we have the next thing we get to talk about is, and let me, you know what, let me zoom out so we can see the whole thing. Yeah, that's good enough. Okay. So we have a system of three linear equations can have one solution, no solution, or infinitely many solutions. Okay. So this is just a visual representation. We're going to focus more in this class more on the solving equation part. So, but I just wanted to kind of show you, if you look online and you want to research what the different solutions look like, if I have one solution, that means it's that point right there in the center, because that's the point where all three colors meet. What I mean by colors, right? We have a green plane, a blue plane, and a red plane. And all three meet at this one location. Like all colors are going to intersect at that one location. Then we have no solution. No solution is when none of the planes intersect. Right? And a plane you want to think of like a paper, right? A plane is like a sheet of paper. And so here, like I have this red plane, blue plane, green plane. None of them are touching, right? Because they're just kind of hovering above each other. Here you would say, hey, I thought you said they couldn't intersect, so there's no solution. But the red and the green are intersecting. Yes, that's true. But is the blue intersecting all three colors here? Or are all three colors being intersected here? No. The same thing for this bottom section here. The blue and the red are intersecting, but not all three colors. Same thing here. I only have red and green. I have blue and red and green and blue. But in this triangle formation, I don't have a situation where all three are touching, making contact. And then the last situation is the infinite situation, where I do have all three colors touching or intersecting, and they're intersecting at this one line. So we're going to look at some examples of equations, not really graphs, but I just wanted to kind of show you what the graphs look like to give you a visual idea. Now let's jump to equations. There's 4 examples today. The instructions are: solve each system of equations, show all your work. Okay, so I'm gonna break down how to solve each one. So let's take a look at this first one. Okay, so we have this first equation, second equation, third equation. And then we have these 3 equations, and so we can think of looking at each of one of them, and we say, okay, is there anything already given to me? And the way that we've set them up is, we usually want to find there's one equation where there's a key piece of information given. There's something already solved. And so, for example, I already know x equals 1. So what I can do is I can plug that into the previous two equations. So let me write the first equation down so you know which one I'm talking about, which one is the first one. So x plus 2y minus 3z equals negative 2. And if you notice, when I wrote the z, I put a line through it so that I can tell the difference between a z letter and the number 2, just so that I don't accidentally confuse it with a 2, right, or something like that. So I usually put like a z, I put a line through the middle of the z. So this is my first equation, and I know that x equals 1, so I can replace it. So instead of x, I'm going to put 1 plus 2y minus 3z equals negative 2. Okay, and then the next thing I want to do is I want to put the numbers together. So what I can do is I can subtract 1 on both sides, and then these cancel. I'm left with 2y minus 3z equals negative 3. Okay, then on the right side over here, I'm going to write the second equation, which is 2x minus 2y plus z equals 7. And again, I know that x equals 1, so can I replace it over here? So again, I'm taking this value and plugging it in here, which I already did, and I'm plugging it in over here. That was a crooked line. Okay, so plugging it in there, it's going to be 2 times 1 minus 2y plus z equals 7. 2 times 1 is 2. Then I want to move all the numbers to one side, so minus 2 minus 2. It's going to cancel these two. Bring down the negative 2y plus z equals 7 minus 2, 5. Okay, so now I have two equations now. Instead of having 3 equations, I used the fact that they gave me x equals 1, and I replaced it into these two x locations from the first 2 equations. Then that leaves me with 2 equations with y and z. Now, one thing that you can do with equations is that you can add them with each other. And the reason we want to consider adding them is because if I take a look at the y's, I have 2y on the left and negative 2y on the right. Aren't these opposites to each other? Positive 2y and a negative 2y? Yes, and what happens if I were to add these two? What's 2y plus negative 2y? They're going to cancel. And so what we can do is we can add the 2 equations. So I'm going to take this equation on the right and put it under the one on the left. So I'm going to copy this equation, So let me erase this green part first, just so it's not throwing anybody off. Okay. 2y, negative 2y. Okay, so what I want to do is I want to move this equation over here. So it's going to be negative 2y plus z equals 5. Right, so I'm just copying and pasting this equation over here. And then I want to add these two equations. So I'm going to add vertically. So here, what's 2y plus negative 2y? 2y plus negative 2y, that's going to cancel. Then what's negative 3z plus z? What's negative 3z plus z? Right, there's a 1 in front of the z, right? So what's negative 3 plus 1? Negative 2z equals, what's negative 3 plus 5? What's negative 3 plus 5? It's going to be a positive 2. And then here, can I solve for z? Yeah. I can divide by negative 2 on both sides. And that's going to cancel these two. And so z is equal to negative 1. So that's one answer down. And the next thing you want to do is, because at the end of the whole process, we want to end up with one x value, one z value, one x value, one z value, and one y value. We want to end up with an ordered triple. Triple means 3 numbers, right? So check this out, right? I know I knew x from the beginning. I just found z. Can I replace the value of z over here so that I can get my last number, which is y? The letter y, right? So I have negative 2y plus, but I'm just copying this, right? Negative 2y plus, I already know what z is. I just found it. Z is negative 1 equals 5. But what happens when I have a positive negative? Can I just write it as a minus? Like this? Yeah. Can I solve for y? Plus 1, plus 1. These ones are going to cancel. I get negative 2y equals 6. Divide both sides by negative 2. And the negative 2's are going to cancel. And so y equals, zoom out again, y equals negative 3. Right, so to recap, right, I took the one value they gave me, I replaced it into the first equation and into the second equation, which when I worked it out gave me this equation here and this equation over here. And what I did was I moved the equation on the right and I put it underneath the one on the left. I added them to give me kind of closer to a solution for z, and then I plugged in z over here to kind of give me the last number. Okay, so my final answer is the ordered triple. That's going to be 1 comma negative 3 comma negative 1. It's x, y, z. All right. So again, we're going to keep practicing this, and then let's see if we see a pattern, right? So let's go to example 2. Okay. So just like example 1, is there something that they gave us to start off with? And you'll notice that they gave us the value of z already. So we already know z equals 2. So let's just follow the same process that we did in example 1. Let's copy the first equation, negative x plus y plus 2z equals 7. And then we're going to take this value and replace it for z. So that's going to give us negative x plus y plus 2 times 2 equals 7. Let's simplify. 2 times 2 is 4 equals 7. Move the numbers together. So if I have a 7 on the right and a 4 on the left, I want to move them on the same side. So I'm going to move the 4 over to where the 7 is. Seven minus 4 is 3. Okay, now let's copy the second equation. Sorry. Okay, and then I'm going to replace this z with 2. So I have 2x plus 3y plus 2 equals 1. Then I want to subtract 2 to put the numbers together. It's going to cancel these positive 2, negative 2. Then I'm going to end up with 2x plus 3y equals, what's 1 minus 2? It's negative 1. Okay. One thing we can see is, for example, I have a positive 2x and a negative x. What can I multiply negative x by to have it match this 2? Right. I can multiply by 2. So if I take all of this here, multiply by 2, and multiply this by 2, multiply the y by 2 and the 3 by 2, it's going to give me, changing colors here, 2 times negative 2 is negative 2x plus 2 times y, it's 2y, equals 2 times 3, 6. Okay, and then the next thing I can do is I can move, let me change colors here, I can move this equation like I did in example 1. I can move this equation down here. And then add the two equations. Let's add them. What's negative 2x plus 2x? It's going to cancel. What's 2y plus 3y? It's 5y. And then what is 6 minus 1? That's positive 5. Then we can divide both sides by 5. It's going to cancel here. And I'm going to get y equals 1. Okay, so if I know what y is, can I plug it in over here? Yeah. So again, kind of like in number 1, 3 times 1 equals negative 1. That's 2x plus 3 times 1 is 3 equals negative 1. Subtract 3, subtract 3. So you're going to cancel here. 2x equals negative 1 minus 3 is negative 4. Divide by 2. Divide by 2. X equals negative 2. So my ordered triple is negative 2, comma 1, comma 2. Okay. Let's look at example 3. Okay, so we start off with one answer given. We write the first equation, copy the first equation, equals 2. We take the first answer and replace it for the variable that's there, right, for z. Then we do x plus y minus, be careful with this one because the z is negative, so it's minus parentheses and negative 3 equals 2. So if I simplify, what's the negative? What happens with the minus negative? Becomes plus 3 equals 2. And then we want to move the number to the other side. So we do minus 3, x plus y, these cancel, plus y equals, what's 2 minus 3? It's negative 1. Okay, and then we're going to copy the second equation, copied on the right over here, equals 4. Replace z over here. So copy 2x, copy the 2y, plus negative 3 But when we have a plus negative, it's kind of like just saying minus 3. Then we're going to add 3 on both sides to move all the numbers to one side. It's going to cancel those two. We're going to be left with 2x plus 2y. Bring those down. Equals 4 plus 3 is 7. Okay, so what we can do, and I'm going to kind of erase this part here, but kind of move it closer to the equal sign. So I'm going to erase the x plus y, but it's correct, but I just want to move it closer to the equal sign. Okay, so I still have the x plus y, I'm just moving it closer. All right, so I have 2x plus 2y and y plus y. X plus y, sorry. 2x plus 2y and x plus y. Can I make the x into an opposite of this 2? Yeah, but whatever I do to one side, I have to do to the whole equation. So I can multiply the whole equation by some number that's opposite to 2. Right, so a negative 2. And this negative 2, I'm going to multiply it out. So what do we get? Right, what's negative 2 times x? Negative 2x. What's negative 2 times y? It's negative 2y. Equals, what's negative 2 times negative 1? It's positive 2. And then I'm going to take this equation here and move it down here. Copy it over there. So it's 2x plus 2y equals 7. And then add these two equations. Alright, so what's negative 2x plus 2x? They cancel. What's negative 2y plus 2y? They cancel. So if everything cancels on the left, I'm going to end up with 0. Equals, what's 2 plus 7? 2 plus 7. 9. Does 0 equal 9? Is that a true statement? Right, it's a false statement. So that means there's no solution. Right, so whenever you're solving and you end up with a false statement, that means that there's no solution. Even though, I mean, you started off with one number, but as you work through the process, you end up with a false statement. Okay, so let's go to the last example. Example 4. Again, they gave us y equals 0. So we can copy the first equation. And then we're going to replace, be careful here, right, because the letter changed. We're going to replace y this time. So we have 3x plus 0 plus 2z equals 4. And here we can just combine it. It's like if there's no number there anymore, it's 0. So I can just copy the 3x, copy the 2z, and copy the equals 4. right? Because anything plus 0 is just the same thing, right? So now let's write the second equation on the other side. And then let's substitute y with 0. So I have 9x plus 3 times 0 plus 6z equals 12. 3 times 0 cancels. So I'm just going to bring down the 9x, bring down the positive 6z equals 12. Okay, so looking at the x's, can I make the x's the same number and opposite? Yes, I can multiply. Doesn't multiplying by 3, what's 3 times 3? That's going to put a 9 in front of the x, right? But I want to get an opposite of a positive 9, so I want to make it negative. So I'm going to multiply by a negative 3. And so if I multiply every term by negative 3, what do I get, right? So negative 3 times 3, negative 9x. Negative 3 times 2, negative 6z equals negative 3 times 4, negative 12. Okay, so following the pattern we've been doing, we've been taking the equation on the right and putting it under the equation on the left. So I'm going to copy the 9x, copy the 6z on the right, and equals to 12. And then we've been adding these two equations, right? So what's negative 9 plus 9? Cancel. What's negative 6 plus 6? Cancels. So I have 0 equals, what's negative 12 plus 12? 0. So, sorry, I'm just going to make an arrow here. So is this a true statement or false statement? The 0 equals 0. It's a true statement. Did I end up with a letter? With x, with x or z? No, right? So I didn't end up with one solution. I ended up with a true statement about numbers. And so this, if I end up with 0 equals 0, then I have infinitely many solutions. Infinitely many solutions. Right. So thank you for joining me today in this video. Again, if you have any questions or clarifications, we can go over them in class. But thank you for joining me today. Have a great rest of your day.